You all. So my name is Saba Malau and my partner is Professor Albiner Siagian. I work at Nomensen HKBP University in Medan, and Professor Albiner Siagian is the lecturer from USU. My paper entitled Stability of Arabica Coffee Genotype Coffee Arabica L against Leaf Rust Hemilia Fasari. I would like to ask you all, can you hear my voice?
Yes.
Yeah, good. Clear enough.
Yes, sir.
If you don't understand, just smile. Okay. So I will present with this scenario, introduction, and then material, method, and result, and then conclusion. So let me say that first is significance of this coffee. Coffee is one of the important economic commodities in the world. Many of us are coffee drinkers, Without coffee, the life is not so good. World production, Arabica and Robusta, in the year 2016 were 9.54 million tons of green bean. This coffee were produced by 36 countries. The big five of coffee producers were Brazil, Vietnam, Colombia, Indonesia, and Ethiopia in descending order. It means that Indonesia took place in the fourth place. Indonesia had 1.78 million of coffee farmers, households. How big, that? And North Sumatra of Indonesia is one of the main production area of Arabica coffee besides Aceh. So now what's the problem? The problem is has been epidemic of rust disease in America, Africa, and Asia. This epidemic in Central America in 2017 covered 70% farms. It means which caused coffee damage and lost income in amount of 3.2 billions, as well as 1.7 million coffee workers to lose their jobs. So let me show you what is the fungus, what is the rust disease. You see that this is the coffee leaf, and this is the symptom of rust disease, just like rust, So this caused by fungus named Hemilia fastatrix. This fungus lives under side of leaf. Fungi that live on the bottom surface of leaf, this photo, can cover up to 100% of the surface. So all this surface can be covered by this rust. So next, the leaves are then damaged. You see them here. The leaves was damaged and eventually fall off. Production reduction caused by this fungus can reach up to 95%, depending of the leaf rust severity and number of abscission leaves caused by this fungus. So what's the solution? All the people, all the scientists, all the interested people say that the only solution is using resistant cultivar. This is the best way. And in some countries, the resistant cultivar is already found, but the problem is interaction between genotype and environment can change the rank of genotype that shows instability of this genotype against leaf rust. It means that if one genotype is resistant to this rust in one area, it does not mean that in other area this genotype will be resistant. So what is my purpose? My purpose of my research was to study stability of genotype of Arabica coffee against coffee leaf rust. So I'll try also to find one or two or several genotypes that are resistant. Material and methods. 7 genotypes of varieties gararutang of Arabica coffee were used. So what I did, spores of Hemilia fastatrix were collected from the rust-infected leaves of the coffee plants that were growing not far from the experiment plot. So I collect from the coffee plant growing near to my experimental plots. And then directly I applied these spores to the experimental plants. So the location in this table 1, this is the location, the name of district, the name of location, and that's coordinate, and also elevation, also climate zone. So A1, D1, D2, and E2. So also climate data were available. So experimental design, a factorial randomized complete block design with 2 factors, namely genotypes and climate zones, with 3 replications were used in each location of experiment. So in 4 locations. So data of brain rust incidence, leaf rust incidence, and leaf rust severity were collected in 2016. It means 6 and 8 months after spore infections. Statistical analysis and stability analysis. So the data from these 4 locations and then was then analyzed with combined analysis. Comparison between values also carried out, and also correlation coefficient. So I want to underline that 17 of the statistical methods for measuring the stability are used in this research. So around 20 methods, but I use only 17. So this method is based on the analysis of variance, regression, and non-parametric. One of them is the method that I and Albiner Siagian. So result and discussion. I have used 7 minutes, 3 minutes to go. Table 2, this is the combined analysis of variance over 4 environments, locations. We see that this research showed that there were interaction between genotype and environment. I make red color interaction. So it means that what? A genotype can perform low resistance in one area but not in other area. And table 3, genotypes show different leaf rust severity in environment 1, 3, and 4, but however not different in environment 2. So you can see that this is the LSD, I give red color to genotype G7 and in LRS because this is then to the conclusion very important. And this is the table 4, rust stability genotype measured by 17 parameters of stability. So I didn't mention before, but now you can see that the authors of the method, Rumor, Plastic, and Peterson, etc., and the last is SMG, Saipo Modi. This method was proposed by me and Albiner and was published in other journal. So you know that G4 had the highest total frequency, 9 performing stability parameters in brain rust incident, and G7 performed 6 SMG, Saipomodi. I give the color red to the G7. So table 5 is correlation among rust variables and environment variables. Leaf rust severity negatively and significantly correlated with length of rainy season, minimum rainfall, maximum rainfall, and average rainfall. I give red color. So because this is a short presentation, so I select only some phenotypes, some parameter. So now we come to conclusion. So I will read and we read together. Genotype of Arabica coffee with high resistance to H. fastatrix could be found. what I found is G7, genotype G7. G7 was the desired genotype because it had low leaf rust severity, only 7.71%. And this number is not different with the others, and perform a stable resistance due to the same leaf rust severity in all environments. So in 4 environments, this G7 is stable and had 6 SMG, Sepomodi. Environmental condition of coffee plantation was the most important factor affecting coffee leaf rust. Rainwater, probably web spores of H. fastatrix. Less length of dry season should be the first criteria for selection of the coffee farms. It means that the less the length of dry season, the better the place for coffee plantation. Because of the significant interaction between genotypes and the environment, the genotype to be planted in an area must be tested in that location first. So there is no generic genotype that can be resistant in all environment. So complex. So if someone finds this is resistant to fastatrix, then we say that, oh, let us try first in the area whether this is true or not. Thank you very much. Thank you for the government for funding this research. I give back time to the moderator. Thank you very much.